going to be using. Now, the three properties of logarithms that we have, that little handout sheet that I gave you guys just a minute ago, I'll pass you one back. It's on the bottom of page 2, okay? Hey, this is just something else. This is going to help with extra notes, but it's just worded a little bit differently here. I'm going to leave these up on the board, go over it, show you guys examples of what this is doing. What we're going to be working on today is expanding and condensing logarithms. The reason that you can do this is because by moving logarithms about a little bit, you're able to simplify things out, and you're also going to be able to solve equations a little bit easier. Okay? For example, this product property is basically when you take the log of some base of two numbers being multiplied together. When you have two numbers being multiplied together, you're basically taking the log of each of those values being multiplied separately. And I'll show you a numerical example here in a second. I'm going to go one at a time with these. So if I'm going to do this product property, this first one, an example of that would be nothing more than, I'm going to go back to it, relax. Jeez. If I say the log base 3 of 2x, it's 2 times x, do you agree? What I can do here is I can split this apart as the log base 3 of 2 plus the log base 3 of x. Now, the reason that this is helpful is because if you have a factor within your log that you can take out with the base. Okay. When you see the examples as we go further, you'll pick up on it, and it is relatively easy. Okay. So that's what the product property looks like. Okay. The other one, the next one is our quotient. The quotient one is division. So if we're dealing with the division of two values in a logarithm, same basic idea. It's the log base b of u divided by v. What that rewrites itself as is the log base b of u subtract the log base b of v. So when you have, excuse me, when you have a value like that, an example of that would be real easy again. Let's say we have the log base 2 of x over 3. I'm trying not to make them simplify it and taking that out. When you do that, what are your two logs you rewrite it as?
2 of x minus 2.
That's all it is. So this can simplify to be the log. Okay? We're expanding in this case. We are expanding. And then the last one is called I think it was called the power one, I believe? Yeah. The power property. What happens here is if you have the log base b, u to the nth power, what you do is you take that nth power and put it in front of the log when you go to rewrite it. So this becomes n times the log base b of u. Okay. And these come into play when you're simplifying out a lot of stuff. It just takes a minute or two to get accustomed to it. So example of that, let's say it's the log of x cubed. What's my base if I don't see it? 10. Good. So I have a base 10 going on here. And if I have a base 10, when I rewrite this out to expand it, I'm going to leave it as, hold on, it would be 3 log of x. That's it. Do I have to write base 10 there? No. You can if you want, but you're just wasting pencil lead. There's no reason to.
Somebody did the graph on it?
I mean, they don't use lead anymore?
No.
No, you can eat it if you want to.
Really?
Yeah, if you want to, you can just. Why? You won't die. I wouldn't recommend it, but you can. We're talking about the.
No, we're going to simplify this. A lot of times what will happen here is that they will mix properties together.
Yes.
Okay? They'll mix properties together, and you just kind of go in the order in which you would do your order of operations. So if I want to rewrite this, log base b of x times y divided by z, it would just be log base b of x plus log base b of y.
Yay! PowerPoint.
Happy point. And that's what it would look like. You're just expanding it out. You're rewriting it out. Okay? What?
Sorry, this is completely off topic.
This
but,
never happens in this class.
You know, one of the residents at work, I was telling him how we had our bed pun and it was like, numbers are complicated, that's why they're always looking for their X. And then he was like, I don't know why.
Did you Google?
No, I laughed.
Nice.
Because at least he like remembered X and Y.
That's
Most
good.
of the residents can't do that.
That's awesome. That is awesome. Mr. Michael, I think you had a question.
What's that property?
This is a mixture of the multiplication and the quotient one. What's happening here is you're going to be able to do more. You don't have to do just one of them. They can be intermingled. Okay. There isn't a rule to this. I'm just showing you an example. Oh, this one down here? This is called the power property. Okay? It's just called power property. So, like I said, what we're going to be able to do here is you're going to be able to rewrite values together. You're going to be able to simplify out logarithms. Let's see. We'll just do a couple of these to start. Oops, that didn't work at all. So let's take a look at what you can do here. Excuse me. So we have log base 3 of the quantity 3 times 9. That tells me that I can split this into two separate logs. Do you agree?
Yes.
Okay. So if I split this into two separate logs, I have the log base 3 of 3 plus the log base 3 of 9.
Yes.
What's log base 3 of 3? 1. What can you do to the other one?
Make it 3 squared.
Make it 3 squared, right?
Yeah.
So what's log base 3 of 3 squared? 2. 2.
3. It's all over.
What? Why should you?
Magic is rewriting 9 as 3 squared. So when you have log base 3 of 3, aren't these two bases the same?
Yeah.
And this is how we're going to be able to start simplifying a lot of these values out. And we're now working with numerical logarithm without having to use logs. Does that make sense? Yes, ma'am.
Where does the 2 go?
It came down using the properties of logarithms. Log base b of b is 1.
Yes.
Log base 3 of 3 is 1.
Yes.
1 squared is, excuse me, this basically undoes itself, the exponent just falls. Remember the rule? When this is an x, it just falls down.
Nice.
It undoes the exponent. It pulls the exponent out.
Okay.
Okay?
What if you can't make it like never mind.
If it doesn't work?
I answered wrong.
No, yeah. Just leave it. Okay? Now the next one, what is this telling you to do?
Power property.
Power property. So you have 5 times the log base 2 of 4, which is 2 squared, right?
Yes. So just 5 log 2.
So now log base 2 of 2 is what? So the exponent drops, you wind up with 5 times 2, which is?
10.
Wait, so the log is 2?
Yeah, that's the property. It undoes itself.
Think of that one. I just.
Okay. Now, yes, sir.
So if it's an exponent, it turns into a coefficient.
Yeah. Yeah, like I said, it takes a little while just getting used to it, but it's really, it's not that bad. And if you think about what you, could I have rewritten this right off the bat, that 4 as a 2 squared?
Yes.
And would that be 2 to the 2 times 5, log base 2 of 2?
Oh.
Oh!
Nice.
It's magical. Okay? Take a look at these.
Oh, it's 3 to the 1 power.
Why?
So the answer is negative.
I like drawing things in pencil when
All right, log base 3 of 1/3.
3.
Now, a couple things you could do here. If you use your quotient rule, doesn't this work out to be the log base 3 of 1 minus the log base 3 of 3? And you get 0 minus 1, otherwise known as?
-1.
Because isn't 1/3 3 to the negative 1?
Yes.
That's another way of writing it out, guys. Okay?
What was that?
You all right, Michael? All right. On the next one, using your properties, you have 3. Since you're going to have a division property here, throw in a parentheses because it's 3 times this stuff in parentheses. Everybody see that? Since the parentheses are raised to the power, which means the 3 has to be out in front of the logs. What's log base 5 of 1?
0.
0. What's log base 5 of 5?
1.
So I have 3 times negative 1. Isn't that what this is if you rewrite it? Yes, sir.
There's no point if we just skip all these steps.
I'm showing how it works.
Is it just lucky that if you did 3 log 5, like 3 log 5 minus 3 log 5, and put 3 in front of each log?
No, that does work. 'Cause it's a distributive property. And by bringing it out in front of it, you're just not. You don't have to do that twice.
Yeah.
That's all. Okay. All right.
Oh, there we go.
Expand this one out.
Oh, that's.
Now, you're going to see this instruction where assuming that x and y are positive, there are little things that happen once in a while if they're negative values. You never have to worry about it in this class because we're not going to do that. So, yeah, some other time. Maybe. I don't remember. I haven't taught that yet.
If you do it now next year, you have to make sure
Yeah. Honors pre-calc, I don't know who's teaching it because next year will be the first year that class happens. Okay. Right now, the pre-calc teachers have traditionally been Mr. Thames, which is wondered by, and Miss Denny. This year we had an extra section of pre-calc, so Mr. Montana did one. But I don't know who will pick it for next year.
What does Mr. Montana usually do?
He always has the calc class, the AP calc class, and then some years he does geometry, some years he does algebra 2. He's something.
Why there wasn't changed it now?
Yeah. Let's see what we got here. So, log base 2 of 7 plus 3 log base 2 of x minus log base 2 of y.
What is that saying? That's all.
The exponent, notice how the exponent is only on the x value? It's not thrown in parentheses. That's the little trick that you'll see every once in a while, whether or not the whole thing gets the exponent or just a singular value. That's the little trick you will find, okay?
And that's as far as they go.
Yeah, there's really nothing else you can, because there's not anything in here you can simplify, because you can't rewrite 7 as a base 2. Not gonna happen. Okay? Not gonna happen. Well, let's look at this.
4, 8.
Wait, it's in the packet? Yeah.
Let's rewrite this one out.
And like all of us,
Hey.
0 degrees, and like,
Is that log 2?
Still really freaking cold.
it would be really cold.
Well then, all right. This might be the one time. If you're looking at this problem, as we walk through this one. This one's tricky. Since the 1/3 values to both values within the parentheses, when you go to rewrite it out, put the 1/3 out front first. Throw your brackets and then simplify out. You get log base 2 of 8 plus log base 2 of x.
Got that, bro.
But then you
I like that, bro.
qualify the log.
But then you can simplify the log base 2 of 8. What do you simplify log base 2 of 8 to be?
3.
3. Excellent. Because 8 is 2 cubed. So now you have 1/3 of 3 plus log base 2 of x. So now you could distribute. Very good. You have 1 plus 1/3 log base 2 of x.
If you like didn't distribute.
Well, you should go as far as you can.
Well, can we just leave it
Like, yeah.
Now,
at 2 of 8?
no, because you can get rid of that log. Now, if you would have, you might have recognized this earlier. That's cube root, right? Could I have taken the cube root of 8 and done log base 2 of 2 right then and there?
Oh.
You could have done that also. There's little tricks that you'll pick up on these things as you're going. Okay? So there's little tricks that you'll find through as you go.
No, we don't need no anymore.
Nope. Let's bring them back in. Let's condense.
Oh, so it's 7.
Alright, I got that first.
Let's walk backwards. Let's look at this guy. Log base 3 of 7 minus the log base 3 of
It's
x.
gonna be log base
3, 7 over x. All it is. Very good. So in this case here,
Oh, wait,
and you're done. Make sense?
Yeah.
Wait.
I said 7.
On 17, you have 2 log base 5 of x plus log base 5 of 3. When you see that plus sign, you know you're going to be multiplying 2 things together. When you see a number out in front of a log, it means it has an exponent. Now, are there parentheses grouping these 2 logs together? No. So what's the only thing that gets the exponent?
3x.
The x.
Oh,
Because it's 2 on the x here.
I thought.
So you wind up with log
That's embarrassing.
base 5, well, 3x squared. Because that's a more traditional way of writing it, instead of x squared times 3. Not so scary, right? All right, do the last 2. Do the last 2. And I might just let you, it might cut you loose. All right, let's check it real quick, and I'm going to give you some problems. So log base 4 of 5xy. Yeah.
Oh, gosh.
That's the toughest one yet.
I know, I broke a sweat. 1/2 log x minus log 4. So you get log. So annoying.
Base 10.
Log of the square root of x over 4.
Could you write it?
Or you can write x to the 1/2, that's perfectly fine.
Okay.
Okay? And it's not the square root of the whole thing because it wasn't in parentheses. Okay? Scary?
Yes.
All right, let me give you a couple of these to try, see how we do. Well, we'll talk about this whole change of base here tomorrow. We don't need to do it now. Let's do these.
I think there's a couple on here that are change base I'm not going to worry about today. So let's Is that what the change of base is? Okay. 59 to 63 is the change of base, so you don't have to worry about it. Which one? 59 to 63, I'm just going to double check. Not that I don't trust you.
All right, so
I'm very trustworthy. I would never need someone's.
Is it 17 through 29 on?
Yeah. Ooh. Yeah, that's fine. So everything with 59 through 63. Yeah, those are change base. Yeah, you don't have to worry about these.
Wait, what's change of base?
We'll talk about that tomorrow.
29 are odds, right?
Yes, ma'am.
When it says evaluate, it just says how what property or simple.
Oh, you know what? 23, I skipped, 23, 25, 27, so yeah.
There are a lot of problems.
Don't do those 25, 23, 27. There's no reason for us to do approximations by hand.
So there's 17, 19, 21.
33, 35, and so on.
Oh, yeah, but we do 29.
And 29. Don't do the ones that say approximate using decimal equivalencies because
Decimal.
you don't need to know how to do decimal equivalencies because I'm not going to make you calculate that by hand. I should, though, to see if you know how to multiply 4 digits together.
Wait, why would you do
Long form lattice.
I
I like lattice too because you can do the log tables.
You don't know how to actually do multiplication. They only use
There's a log table. So here's all your logarithms for base 10 numbers. And then you'd have to use change of base and do all this multiplying and dividing by decimals. It's awesome. Good luck with that.